Assalamualaikum. Hi everyone. In this video we are going to look on how to do simulation of the first order model by using Excel. To start with Excel, we must first write down the equation of the first order model in time domain equation. So in time domain, this is the equation we are going to use as we discussed in the previous video. Then all you have to do is to prepare the Excel file and divide the column into several columns as follows. The first column will be T or time. The second column will be K or the process gain. The third column will be M, the magnitude of input. Yeah. And then the following column is tau, the given time constant, and then t over tau to implement this equation, and then minus t over tau, this one, and then exponential minus t over tau, and then 1 minus exponential t minus t over tau, this term. And then we multiply all this equation, km, and also this exponential term. And then the following column is, in the J column, is to provide the initial value of y. And the last column is the simulated output, or the y sim. Next, let us consider the following FO model, which has been discussed in the previous video, where we have the process gain for the time constant 5. Rewriting this FO into time domain equation, we have yt equals to 4, 5, 1 minus exponential negative t over 5. So in the previous video, we already learned that this transfer function will produce the response similar like this, where this is the input and this is the step response output. Next, we will prepare our spreadsheet by using the previous template given. So on the first column, we have the column of t, so we can start t from 0 until 5. This is the value shown in this video, but you should simulate up to maybe 30 or 50. Then in the next column is the k, which is the process gain. So the process gain is 4. So let's fix 4 throughout the simulation period. Then m is the step value here, which is 5. So the step value, which is 5. So we write 5 over here, and we have tau equivalent to 5 from this equation. So if we look at this equation, tau is equivalent to 5, where here also we have tau equivalent to 5. So we write down tau, and this is the value of t over tau. So we have t here, divide by 5, we have tau over here, t over tau here, and then we minus that value, and then we exponential the value, and then we include the 1 minus exponential, and then we multiply this value with k here and m. So we have this value, and then in this column we have the initial value. If we look at the simulation, we have 140 degrees Celsius as the initial value of the simulation. So the response will start at 140 and go above during the simulation. So we start with initial value, so we write the initial value here all the way down, and this is the calculated value where the y sim is equivalent to this column plus the initial value. So if we look at this given example, the at time equals to 5, we have the value approximately at 152.6, which is similar to this value at time 5. Our calculated value is 152.6. Next, we will look at the overall simulated value. So this is the plotted simulated value from the final column. So we can simply plot up to 30th value of time. So we can get this response, which very similar to the one given in the example. So that's it.